I want to ask you one more. You are the only girl, only Latina in your class. How does that happen? How does it happen? How do you break the mold? How do you break the societal mold? How did your mom put you in position? Answer all those questions.
Okay, so firstly, I think what motivated us as like first generation is seeing my mom struggle.
Yep.
Don't cry. Why does this make me sad?
I guess it's real.
I've been emotional lately.
Yeah, well, your mommy worked hard for you and you're making her proud. Drum roll, please. Introducing the full-time college student, wife, greatest stepmother in the world, full-time YouTube creator for 3 different channels, and worker all at the same time. We're here on campus, electrical engineering student. Tell me how you do it. You like that intro?
Yes, I do.
That was a good intro, right?
Tell you how I do what?
Yeah, to everything. How do you balance everything?
I can't.
All right, so
I'm breaking down.
We're here on campus on your day off.
Yes.
Show me your, what do you do today? What do you do?
Okay.
You're on your day off.
So actually these 2 buildings, this building here and this building here, are where pretty much all the classes for my pathway are.
What's your pathway?
Electrical engineering.
How's that? How are you an electrical engineer, a full-time YouTube creator, a full-time mother, a full-time wife, a full-time worker? Let's walk and talk around campus.
Okay.
You tell me how you do it. Take us into your labs. I want to see your lab.
Yes.
You do a lot of hands-on things, electrical engineering.
Yes. How do I balance it? You know, I just try to make time for everything.
Yeah.
Sometimes it's hard. Like some days I'm not able to study because we're doing.
What's this?
You brought it.
I did bring it. You forgot it and I brought it.
Yes.
On our way here, she's like, I forgot I want to show this on YouTube, and I had it the whole time, and I didn't want to tell her.
That's so funny.
Yep.
This is
the things
what
you
I work
do,
with.
right?
Yeah, yeah.
Right, so
I could explain it later.
Oh yeah? You can't explain it and walk right now?
Okay, you know I can. Okay.
Look at that, and this is like minute things you do, but what is that?
Okay. So the basics of like engineering is that we study and we measure the current or the electricity that goes through a piece or like a component, right?
Okay.
And then you could look at it individually or you could look at it as a whole piece that's set up already.
Okay.
The purpose of that is to either see how much is going through it or see how much noise that is like going in it as well.
Okay.
Noise or like other signals that could interfere with the system itself.
Okay.
So we can measure that with like machines that they have inside. I don't want to use the actual terminology because people are going to be like, what?
Okay.
But like there's machines that we use to measure all that. But basically the setup of this, right? This is called a timer.
Okay.
And this timer allows for certain...
All right. There you go. You're still studying.
No, I knew. I get nervous.
All
okay,
right.
this timer just basically opens and shuts a switch off, allowing current to come in or come out at certain times. And then this piece has different sections in it, basically. And what it does is that it allows one signal to go in at a time.
Okay.
At certain time frames.
Okay.
So it's like, it has, let's say 4 signals in it.
Okay.
The timer helps with the time frame, and then signal 1 goes, 2, 3, 4, and then...
Okay, you gotta take us into your lab and show us because it's like gibberish to me.
Yeah.
And probably every other non-electrical engineering student.
Yeah, that's like simple terms because there's actual terms for it that
What's that
wouldn't
board?
make sense.
What's that board?
It's just called a breadboard. Obviously, you see like the positive and the negative. So this little wire.
Obviously.
Look, it's a plus and a negative.
Oh, okay, got it. I can see that, okay.
This little piece, you'll connect the power source here, like the electricity that you're gonna put in. And then also you'll connect a ground, which is like no electricity.
So smart.
So you get current through the whole thing.
Okay, so
and it powers this board.
You do this, obviously you're a full-time student. You're a YouTube creator.
Yes.
You cook, clean. You take Emmy girl to school. You do, like, there's so many things that you balance. How? What's your day like? What's your time? It's currently 9 o'clock in the morning. What'd you do today?
Like schedule-wise?
So
okay.
Tell me your schedule today. It's a day
today
off.
I actually...
You didn't have class today, but somehow you're on campus.
Yeah, because we need to study. We both need to study.
True.
But I woke up late.
Yeah. Late
usually,
as in what? 7:30 in the morning?
Like a little later than that.
Okay.
Because usually I help you like cook breakfast for Emery, but I didn't do that today. I slept in.
Okay.
But I woke up and then I got Emery dressed and I did her hair for school and then we took her to school and then we came here.
Okay.
And that's usually how the mornings start.
Okay.
Like I usually, I was walking some in the morning, but now I got a little lazy.
Yeah. We still have to get home, pick Emery up. We have to study, make sure we go get her from school.
Yeah. So usually what we do is the time that Emery's in school, we try to get things done as well because, you know, it's easier because she's not around in a sense.
Okay. That's how you balance being, the mother side of things. Now, how do you balance the YouTube creation for your other channels?
Oh, so we split it into days.
Yeah.
Yeah. So like I'll draw, or I'll like practice my drawings.
Shoot your channel.
Like one night, and then the next morning, because we need good lighting and stuff for the video, we'll shoot the video, and I'll do like 2 or 3 drawings at once. Okay. Just for the week. Okay. And that's like its own thing that takes like 3 or 4 hours to do.
Work one, like work, because bills need to still be paid, right?
On the weekends.
On the weekends.
Yeah.
So you still find enough time to study, get A's and B's, while balancing all this stuff.
More like B's. I haven't seen an A in a while.
B's definitely get degrees.
Yeah.
All right, so take me to, I want to see your lab.
Okay, so we got to go upstairs here.
Go and study and hands-on stuff.
Yeah.
I can definitely attest that right now there are multiple different campuses. This is the West Campus. This is mostly where the electrical engineering students come.
Yeah.
I'm over on East Campus. I'm a software engineer, but I can definitely attest that software is hard and developing software, and some people say that like looking at code makes them confused. But I think your degree is like 10 times harder than my degree. This girl has notebooks full of notes, like thick notebooks, like thick notebooks, front and back of just notes and calculus equations and this and that.
I'm like still old school in that sense, where I like writing my notes because it helps me memorize the things more.
Somebody might be feeling this that's watching this. Somebody might be like, that's how I study. Yeah,
that's how I have to study. Like I have to write my notes and I have to read it over and look it up and just like.
Okay.
Takes a little longer, but it helps me.
How'd you get to college, right? Well, let's talk a little bit about that, about your past, right?
Okay.
Your mother came over to this country.
Yes, when she was 28.
When she was 28, she migrated to this country. Your brother went to college. You went to college. Your sister's very successful.
Yes.
How was that growing up, though? How can your mom migrate here at 28 years old and all of your siblings be successful? How did it happen?
I believe it's because we...
Sorry, before you answer that question, I want to ask you one more. You are the only girl, only Latina in your class. How does that happen? How does it happen? How do you break the mold? How do you break the societal mold? How did your mom put you in position? Answer all those questions.
Okay, so firstly, I think what motivated us as like first generation is seeing my mom struggle.
Yep.
Don't cry. Why is this making me sad?
I guess it's real.
I've been emotional lately.
Well, your mommy worked hard for you and you're making her proud.
I don't know if I'm PMSing or not. No, but yeah, I think that motivated us, in our own ways, differently, or like in different time frames of our lives. But that's always the motivation, She worked so hard for us, not being able to speak English. And now in a country that she doesn't know,
Look at you. You're on the hardest degree at Valencia College. Doing your thing, making her proud.
Yeah, but when I lived in New York still, I did go to college, but I didn't take it seriously.
No direction, right?
No direction. I didn't know, no direction, not knowing really what I wanted to do with a degree. Okay. And then I also, childish mentality. I had a really good job for my age at that time. And I was making really good money, and I was like, I don't need to be in school right now.
So you decided to go back to school, pick the absolute hardest major, balance a major, balance being a wife, balance being a mother, balance being a worker, balance being a YouTube creator, all in one. You're doing an amazing job.
Thank you.
I thought I needed to bring some light to YouTube to let everyone else know, every other struggling, maybe minority group, that they can also do it too.
Yeah. And as far as your question for being a woman, or a Latina woman,
the only woman in all your classes.
Yeah, and one of my other classes I have 2, but a lot of my classes I don't. I know, I felt it going down my face. And it's empowering. It's a little intimidating at times.
The world needs you.
Because girls aren't known for these things, to have STEM jobs or be smart in that sense. But it could be a little intimidating, but it's also empowering. When I sit there and I'm like, wow,
you set an example for Emery, and you set an example
I might be smarter than some of these people in here, you know?
I think you are. You're very smart. All right, so I'm following you.
Yeah.
Bring me into your open lab.
Not after I cried.
So if we do go into open lab, we don't have to interrupt anybody studying. I'll just kind of record. And I'm sorry, before I went in, I wanted to explain that.
Okay.
Interrupt anybody.
Yeah.
If it's open, then it's a free for all.
Well, it's open.
No, I mean open, if there's no kids in there.
Well, no, the thing is, that's why I said he also came because he's going to study his own thing, but like, I wouldn't study in there because everyone's talking, so it's not really like you could focus in a sense.
Got it. Okay. Well, I remember this building. I did one of my projects out there.
Oh yeah.
I remember. Yeah, I was.
Yeah, down here is nice.
And then I got up and I went to go sit outside because it was nice.
Yeah.
And I built like a software project out there.
Yeah.
I was sitting out there on the balcony and I built a project out there. Oh.
So look, this is also like an engineering. Lasers and stuff, you know, like photonics and stuff, and also like 3D printing and things like that.
You printed from kids?
Yeah, from students.
You could do this for one of your projects, no?
I would have to build something, yeah.
For your senior project, you have to build something? Oh, that's pretty cool.
Yeah.
This is like a robotic hand or something?
Yeah, that, I'm sure if all the wiring.
This is a drone.
Yeah,
No?
yeah.
I think this is a drone.
I think so
too. And a
too.
student built this? That's pretty cool.
Oh no, there's a class in there right now. I wanted to show you. No, there's just a class in.
I might be able to get like a little bit of a recording. What is that?
No, this is the open lab here.
Oh.
Hello. Hey. So this is the open lab.
Said that we can record it here?
Yes.
Awesome.
So this is what I have here, right? Mm-hmm. And basically what we would do is those wirings in the back, they're meant for certain things, like these would like allow me to put current into the board or like power into it, and then the other ones are used to like actually measure and see waves from them. So certain connections will be connected here or to like the start of my circuit. That's the right word. The start of my circuit, I would connect it to the start and the end, and doing that I would see sine waves, or I would see waves that allow me to read how high the amplitude goes or the frequency, how much current's going through it, how much current is lost from the beginning, because you could start with 10 volts, right? Or 10 volts is like the electricity that goes through it. And because all the components, they have certain resistance or tolerances that you won't get 10 at the end. So I'd be able to measure that and know which ones to use in a sense, so I could end up just getting the amount that I want.
So you have taken a bunch of classes through your pre-bachelor's. You're now in the first semester of your bachelor's. How's it going? How do you feel?
It's well. I think it's a little challenging for me because I've never touched this ever. Ever. I've never really been.
That's why you're here on your day off trying to get more practice.
Yeah, I've never been tech savvy either. Like, like it's all a new experience, but it's cool to learn and it's cool to play with. It's a little overwhelming and frustrating when you do fail. And you can't get something right. But afterwards it's very satisfying, obviously.
What was another question I wanted to ask you? How's it going? What are your projections? What do you think? What do you think the future holds? What do you hope to gain from this?
That's a great question.
What do you love about learning this electrical engineering? What do you want to do? There's different fields, robotics. There's power plants. There's you're still super new into your bachelor's, but you don't have to have the answers right now. What do you think?
I think what I really want the outcome to be is just I want to grasp all this material and really know what I'm working with and what I'm speaking about. In order to get a good job, specifically like what job I want, I'm not too sure. I think
different lanes you can go into though, right?
I could just practice different things, but
what is this board? What is this board? What are these things? What is this?
This, if we turned it on, right? Oh, this might go there. Let's go there. So, if I show you.
Looks like an old radio.
Look how cool this is. If I go here, and maybe because different letters mean different things. This is called the resistor, right? So
this is a resistor in your hand?
And what it is like in its name, it resists current from going through. And it allows like the circuit to not like overheat. But if I put this here, and maybe it won't turn on, it would read how much it has. But it says offline. I don't know why this one's not working.
What is it? So what is it doing? Say it one more time. I'm sorry.
It just reads how much
current is going through this.
No. It reads what how much power this one has, or how much this piece itself.
This machine allows you to read how much power
this has alone.
Okay.
Right. So
you could put different pieces in here.
Yes. So you could.
Got it. I understand.
You see, it's 22 kilo ohms.
Okay, so you can take a bunch of things off this board, put it into this
and measure
machine.
it. Mm-hmm.
I understand what this is.
So that's what this one is, right?
Okay.
This one, if you put your wires in, you see it says V for volts or ohms, which was what we measured.
Okay.
This is your power, which is the blue, and the black is ground, like no power.
Okay.
You could set this, or you could read it to have a certain amount of voltage in it.
Okay.
Which you could adjust here if it was to turn on, like you'll move the knob.
Okay.
And it's like 12 is the standard that you could set, or you could adjust it to put it lower.
Got it.
So that's what that one does. This is where we read the waves and stuff. These are channels. This one only has 2, the newer ones have more, but...
Looks complicated.
No, not really. You just have to know basically where you would start and where you would end.
Okay.
Or you could even, if let's say there's like 7 pieces, you don't necessarily have to read the whole thing. You could just read parts of it as you go.
All right, so what?
Yeah, so this is also cool because if you set up like a circuit that you want to manipulate, like you know how I said there's timers?
Okay.
And you could see when it's on or off.
Okay.
There's other pieces or chips that only work if both of them have high inputs.
Okay.
It's called like and or is like either one could be high, but like these LEDs, if you connect it to where they are, most chips have like 3 pins. 2 are inputs and 1 is an output, meaning like you'll see what ends up coming out. You'll connect it to the out to see if the light is on, meaning if it's on itself. Okay. So it's just like cool little gadgets that let you see these things.
Got it. Okay, last question before we go and study. What made you decide to go back to school at 26 years old?
What made us decide?
Us. This isn't about me right now. This is you. So you mentioned how you first started going to school, but you had a job that was paying you a lot. You ended up dropping out. What made you revisit this and take this up?
I think our goals were, or my goal, but it's ours because we're together. You know, our goals were originally to make money, bartending, and to be able to move around with that money and just explore being business owners or whatever the case was. And then I think we also realized that it wasn't ideal, or it wasn't like
kind of needed an education, huh?
Yeah, it wasn't like realistic in a sense, because yes, it could happen, but the way our lives are with a child and the things, the responsibilities we have, like it wasn't realistic for us. And then there's really, I mean, everyone has different outcomes in life, but it only made sense for us to go back to school.
Got it.
To have a good and successful life.
All right, so when I go work on my software project, what are you going to do right now? Why'd you come here? What do you need to work on? What do you need to study?
I don't really have anything due right now, but I wanted to get a head start on my next lab.
Got it.
Because they usually take me a while.
So you have a lab due soon?
The following week.
Okay.
But what we learned in class this week is what's going to be for the lab.
Can you show us what you're doing with your lab?
I could show you, yeah.
You don't have to show us right now, but when you get started.
Oh, yeah.
Okay.
You could come up here or call you up.
All right.
Alright guys, this part of the video is ASMR. Just kidding. So I'm going to explain the board I showed you guys earlier, and the 2 wires I just touched, the red and the black one. The red goes to the power typically, and then the black goes to ground. That's how it is in cars as well. I don't know if people have noticed that, but that is connected to our power source, which puts the power or the voltage into this setup or circuit that we've built, or I've built. So this little thing I'm touching here is a timer, and if I connect it to those silver little legs that you see in the right hole, it allows me to see its output or what it releases, which is this. This is a DC wave, meaning there's only 2 signs, which is high or low. And when it's high, messages could go through. When it's low, it's off. So this one is called a potentiometer, and it basically controls or adjusts the frequency that goes through the timer allowing it to either relay messages for a longer amount of time or a shorter amount of time. That really depends on how we adjust the knob. This allows me to see the wave of it. So this little pink wire is connected to the right pin and it's grounded like always. And from here, this is also where my frequency is going in. So the red one and the black one. That one's connected here. And if you could see, it says 150. And like I showed the pink cable, that's going to show me the wave. It's going to look different. It's going to look more like waves instead of boxes. That is what the potentiometer shows. So this adjusts, or this affects my timer, like I've said earlier. So adjusting this would give me higher frequencies or lower or flatline, depending on what I need or what I want, or how fast I want things to be delivered or messages. That's that part. And I could show both of them side to side, which is this. And typically at the high of the timer or the high of the yellow, you'll see the high of the purple, because that's when it's on. And it's relaying messages, like I said. This is an IC. And it has, if I'm not mistaken, 3 or 4 slots or 3 or 4 different channels where different messages can be relayed. Usually it's different because they are set at different frequencies, like radio stations or radio channels. And if I turn it on, you'll see this wave, which is the blue one. And this is the combination of the yellow and the purple. This is like the final display or the final output of everything, all tied together. These are called capacitors. They store energy and release it when it's needed. So that helps balance out our circuit or our setup. And these are all 3 waves put together. The peaks here are usually the peaks here as well. The sine waves look like they're moving more because I didn't adjust the scale enough, but that's okay. Here, if I adjust the voltage or the power that's going in, you'll see that affect the yellow part. So look, if I adjust that knob, it either goes higher or lower. If I put more voltage in, that means the timer is set on for a longer amount of time, and then vice versa. This is our frequency knob, and this adjusts how frequent the waves are shown. So here, if I adjust this knob, it could spread out more, meaning it takes a longer cycle, or a shorter cycle if I go the opposite way. And this is the adjustment to where I turn the knob right now. And that's pretty much the setup of this board. Thank you.
All right. You look visibly stressed.
Defeated.
That's good.
Yeah.
So what went on?
So like I showed you guys
Where are we going?
a setup that way.
Okay.
Yeah. I showed you guys a setup, so I did that to show you guys, but then I started another lab that I was working on. And
Yeah.
it got nowhere.
All right, we've been here for like 4 or 5 hours.
Yeah.
We have to go get Emmy girl from school.
Yeah.
We did discuss briefly you updating or upgrading your major to something specific with electrical engineering. And what were the options that we discussed?
Either
So we discussed.
upgrading the major.
Yeah.
Yes.
What were the options?
Either robotics or photonics, which works with lasers and lights and speed of light.
Why do those
optical.
Why do those rhyme for? Which one are you gonna do? Which one are you thinking? I like robotics. You seem to like
You
photonics.
do, yeah. I do more because it kind of goes into everything. Like robotics is just like kind of
More specific.
It could be like more broad, but like when you think about it, you think about like the mechanics of like building a robot and doing this.
Robotics
But,
could
like,
also be computing too, no?
yeah, like the
Yeah.
software side, but I don't want to do that.
I got you.
And then I feel like photonics goes into everything. It goes into robotics as well. Cause
That's
you
true.
need-
Okay.
Yeah,
I like that.
so it's more of like more opportunities, I guess.
Uh-huh.
So
All right. Well, let's wrap up this day on campus. Head to the car. Grab some lunch. Go get Emmy girl from school. Go home. Do her homework.
do her homework.
Then do more of our homework.
Yeah. I need you to show me how to download something on my computer.
I got
See,
you.
I don't know how to do things like that.
That's where I come into play.
Yeah.
Good job. Well, good job on campus today, babe.
You too.
Thank you for
Thanks
bringing
for
me
joining me.
Yeah, thank you for bringing me into your world. I know it's chaotic. I know you're stressed out. But we're going to post this 5 years from now. We're going to look back at this posting 5 years from now. And you're going to be...
Wow. And I'm going to sound more like I know what I'm doing.
Yeah. Yeah, that's true. Good job, babe. Thank you.
Thank you, guys.
Peace.